The moon, our constant companion for thousands of years, is quietly drifting away at a rate of about 3.8 centimeters per year. That's roughly the speed at which your fingernails grow. Seemingly insignificant, yet on a cosmic scale, this departure is reshaping the future of our planet. After guarding Earth for 4.5 billion years, the moon has decided to head into the deep, dark void of space without looking back. As it recedes, the familiar tides, the rhythm of our seasons, and even the length of our days are undergoing irreversible shifts. To understand why the moon is leaving, we must first understand the gravitational tug-of-war behind the tides. The moon's gravity acts like an invisible hand, constantly pulling at Earth's oceans and creating two massive bulges. However, Earth rotates much faster than the moon orbits it. Like a spinning top, Earth tries to drag these tidal bulges along with it. As a result, the bulges stay slightly ahead of the moon. This creates a strange physical phenomenon. The leading bulge exerts a gravitational pull on the moon, giving it extra energy and causing it to accelerate and drift into a higher orbit. In return, Earth loses rotational energy. It's like a secret energy trade. The moon steals Earth's spin to buy its ticket out of here. Because Earth is constantly transferring its rotational energy to the moon, its spin is slowing down year by year. This means days on Earth are getting longer. In the early days of Earth, the moon was much closer, and the planet spun like a maniac. A day lasted only 6 hours. In that world, the sun rose every 3 hours, winds were fierce, and the environment was harsh. As the moon drifted away, days stretched to 12, then 18, and finally our current 24 hours. Scientists calculate that every century, a day on Earth increases by about 2 milliseconds. It sounds tiny, but over billions of years, it's enough to change the evolution of all life. If life had stayed in that 6-hour era, human civilization might never have emerged. The moon's greatest contribution is acting as a stabilizer. Earth's axis isn't straight. It's tilted at about 23.5 degrees, which is why we have seasons. The gravitational pull from the moon's massive bulk stabilizes this tilt, preventing Earth from wobbling. Without the moon, Earth's axis would swing wildly between 0 and 80 degrees. Imagine Antarctic glaciers suddenly moving to the equator, or lush forests being flash frozen into permanent winter. As the moon moves away, this protective shield weakens. In the far future, Earth's climate will become terrifyingly unpredictable, like a roller coaster for all living things. We live in a moment of incredible cosmic coincidence. Although the moon is much smaller than the sun, it is exactly 400 times closer to Earth, making them appear almost the same size in the sky. This allows us to witness perfect total solar eclipses. But as the moon recedes, it appears smaller and smaller. In about 600 million years, the moon will be so far away that it can no longer cover the sun entirely. Total solar eclipses will be gone forever, replaced by ordinary annular eclipses. That will be humanity's last chance to see the solar corona. If you traveled to that time, you'd see a moon that looks smaller, colder, like a stranger passing by. Today's tides are driven by both the moon and the sun, but the moon does most of the heavy lifting. When the moon gets far enough away, tidal forces will weaken significantly. The oceans will fall silent, and waves will only ripple from the sun's faint gravity. This would be devastating for shallow water ecosystems that rely on tides. Ocean circulation could stall, and nutrients from the deep would never reach the surface. Worse, without the moon's pull, Earth's rotation could slow to a terrifying crawl. A single day could last weeks or even months, baking one side of the planet into a wasteland while freezing the other into a wasteland of ice. Will the moon drift away until it's gone? Physics tells us the drift will eventually stop. Theoretically, in tens of billions of years, Earth's rotation will slow down to match the moon's orbital period. At that point, the two will become tidally locked. Earth's day will be incredibly long, and the moon will hang motionless over one side of the planet, never setting, while the other side never sees it at all. But this is just theory. Long before that happens, the sun will expand into a red giant and likely consume or destroy both the Earth and the moon. This 5 billion-year farewell will be cut short by the sun. The moon's departure makes us realize that Earth being an oasis for life isn't a given. It's the result of countless cosmic coincidences, the right distance, the right-sized satellite, and the perfect rotation. The moon isn't just a giant nightlight. It's the stabilizer of our entire biosphere. Every breath we take and every change of the seasons owes a silent debt to the moon. When we look up at night, we aren't just seeing a glowing orb. We're seeing a friend who is slowly leaving us. The moon is trading its presence for Earth's stability, reminding us that in this changing universe, nothing is forever. From the microscopic division of cells to the macroscopic movement of stars, the essence of the universe is constant change. The moon's departure is an elegy of time. It tells us that the glory of human civilization is happening in a very brief, lucky window. We assume the stars will always be there, but the universe's script already has its chapters of goodbye. This sense of loss gives our existence meaning. Because we know the tides will fade and the moon will one day be out of reach, we should cherish this brilliant world we have now, with its tides, its eclipses, and its precious 24-hour days.